Let's start by adding a new class called Trie. In this class, we're going to have a private class, node. We could also call it Trie node, either works. In this class, we need three fields. One is a character field called value. The other is children, which is going to be a node array, so children. And here we initialize this to a node array with 26 elements. Now, someone looking at this code might wonder, what is this 26 here? This is what we call a magic number, and it's something that you should avoid. So to improve this code, we can declare a public static integer field called alphabet size and set it to 26. So I made this field static so we can set it from the outside before creating a trie object. And now instead of using this magic number over here, we can use alphabet size. Now our code is more expressive, okay? And the last field, private boolean, is in the word. Now I would like to create a constructor here because we're going to create a node object and give it its value. So let's generate a constructor and initialize the value field. So we pass the value from the outside and simply set the value field. Nothing new so far. Also, I would like to override the toString method. So I'm going to use the generate palette. If you're wondering what the shortcut is, that is Command and N on Mac and probably Control N on Windows. If it doesn't work, simply go to the top. From the code menu, you can find the generate command. So let's generate the toString method. Now IntelliJ is asking, what field do you want to use to represent this object as a string? We only want to use the value field. Okay. So it quickly generated the toString method for us, but this expression is a little bit too complicated. I would rather simplify this. So let's get rid of the first line, bring this up, and also let's get rid of the ending brace. That is better. So we're done with our node class. Let's also put a vertical space here. That makes our code cleaner. Now, every trie should have a root. So declare another private field. Private node, we call it root, and set it to a new node with a white space. Now we're ready to implement the insert operation. So public void insert, we give it a word. Now we start by declaring a variable called current and set it to the root node. Next, we need to iterate over the word we're inserting. So a for each loop for character in word to character array. Again, nothing new so far. Now, in each iteration, we have to ask the current node, do you have a child for the current character? So first we need to calculate the index of this child. That is very easy. We set index to character minus a. Now we go to our children array. So if current, the children of index equals null, if we don't have this child, we're going to create it. We set current, the children of index, to a new node with this value. Then we set current to point to that node. So current, the children of index. So if we don't have this node, we'll create it. And whether we have it or not, current will eventually point to that node. Okay. Now, after this for loop, once we have visited every character in this word, the current variable references the last node for the last character in this word. So we set current dot is end of word to true. That's all you had to do. Now let's test this. So back to the main class, we create a trie object, new trie, and insert a couple of words. Let's say cat and can. Now I want to do a print line here, done. Then put a breakpoint on this line and run the program using debugger. So let's see what we have in this trie. We have a root object, which is empty. Now let's look at the children of this root object. We only have one child at index 2, and that is C. So if A is 0, B is 1, then C is going to be 2. Now, this C node has one child, that is A at index 0, and this node has two children, one for the N and one for the T. Both these nodes represent the end of a word, okay? So this is how we build a trie. Now, the problem with using an array to store the children of a node is that every time we create a node object, we're allocating an array with 26 elements. The Java debugger doesn't show these elements because initially all these elements are null. So when we was debugging this program, we only saw the elements that were initialized. But allocating an array with 26 elements for every node that we create is going to waste a lot of space. Here we have only 2 words. What if we have 1,000 words? All these arrays are going to waste a lot of memory. In the next video, I will show you how to use a hash table to solve this problem.